The new and improved control panel PC boards are back, and today we're going to get set up to manufacture the red lenses for the display. Welcome back to Cloud 42. I'm James. As usual, I am working on many projects all at the same time, but today we're going to get back on the control panel for the electronic lead screw. Last time I designed a PC board based front panel with silkscreen lettering, and this time we're going to work on some tooling so I can manufacture the red lenses that go over the display. This is the control panel that we assembled for the electronic lead screw last time. The front panel is a PC board that I had manufactured. And you remember I wasn't happy with the silkscreen on this, with the font. It's a little hard to read. It works, but it just didn't come out the way I wanted. There's also copper only on one side of the board, so it was warped a little bit. So I ordered some new ones, and they are now in, and as you can see, the writing is much more legible. Used a different font, it's much darker, much easier to read, and the boards are now much straighter because there's copper on both the front and the back, held back from the openings about 5 mil or 5/1000ths of an inch, and then that's hooked into the plated through holes in the corners, so the screws will ground it to the chassis and maintain as much shielding as we can. So these are ready to go. Let me disassemble this. The next thing that I want to work on before I throw these up for sale, the whole thing is really a system, right? There's a PC board with the buttons underneath here and the display. You've got the PC board control panel on the front, but then there's also a lens that goes between them. And the material choice for that lens has proven a little bit tricky, and the thickness of that lens then affects the fit of the buttons. So I've been searching for good material and a good way to manufacture these. Let me tear this apart and I'll show you what I've got. So in this stack up, we've got the PC board and the plastic spacer to hold it back, and then the buttons that are just sitting on top there. They're just captured because they're stuck in. And for the lens in this one, I've got an adhesive PVC film. And I'm not a huge fan of this stuff for a few reasons. One is, obviously, it sticks to the display, which then makes this hard to disassemble. I've played around with just leaving some extra space over the display, especially since from board to board, sometimes these are not entirely seated to the same depth. And so they can't always be level with the front of this plastic spacer because they're all a little bit different. And so if you have it too low, then the display bulges and you see reflections in the curved surface. If it's too high, then there's a gap between the adhesive film and the front of the display, and everything is fine until you accidentally touch it and push it down and it sticks. And then it looks like it's got a big dark fingerprint in it, and it's really strange. So I've been trying to find an alternative to this clear plastic film. The other thing about this stuff is it's pretty thin, and so I've felt the need to put something else over it. So in this case, I've got a sheet of clear plastic that goes over the top of it to provide protection, and then the red filtering provided by the PVC film underneath. And the two-part solution, it's more moving parts, it's more thickness, and I've been looking for a material that I can use for the lens that's hard enough and thick enough to be used as the protective lens and is the transparent red color for filtering to make the display easier to read. And let me show you what I came up with. I ended up trying a number of different products. This one is very similar to what's here. This is an adhesive backed PVC film, and so this peels off. This stuff's a little bit thicker, but it's still pretty thin and it's still pretty soft. And so when you try to use it in this kind of an application, the adhesive is still a problem with the different heights on the display. So I got some of this to play with it, hoping that it was going to be thick enough and rigid enough, but it really isn't. I'm really not happy with that. I have kind of an ulterior motive in looking through some of these different materials. I really would like to be able to laser cut the parts. I'd like to be able to laser cut a piece with all the right mounting holes and the cutouts for the buttons to fit into this space. And of course, this stuff being PVC is a chlorinated plastic, and so it releases chlorine gas when you laser cut it. So this stuff is not really safe to laser cut. It's the other reason I've been looking at other materials. I've looked at this. This is polystyrene sheet, commonly available through model suppliers or hobby shops. And this stuff is great. This can be cut with a laser. It's not ideal, but it can be cut with a laser. It's fairly thick. It's rigid enough that I could use it as the primary as the primary filter and as the display protection. But the problem is that the pigment that's in this is going to be really hard to see on camera, but there's so much pigment in it that it reflects back so much light from the front that it doesn't really work as a clear lens. And so it actually makes the display much, much harder to read. So while this would be ideal because I could laser cut it, it doesn't really work as a filter because it's not transparent enough. The only other material I could find without going to like a 3mm thick acrylic is this stuff. And this is PVC sheet. And this has actually got a protective film on the front and back, but it's thick enough to be good protection for the front. It does have the red filter, and it is transparent enough that it doesn't reflect back light from the display, and so it actually does end up making the display easier to read. Unfortunately, this stuff is not laser cuttable because, again, it is chlorinated plastic. So this is going to have to be cut mechanically. So I've been playing around with some ideas, and what I think I'm going to do is I'm going to try some things today. I'm going to cut a rectangle, the correct shape to fit into the space, and then I'm going to make a jig on the CNC machine so that I can take a whole stack of these little rectangles of plastic, stack them up, clamp them in place, and just drill through all of them at once with the milling machine. And I'm hoping that that'll allow me to make a large stack of parts with just like a few seconds of operation on the machine, and that will be efficient enough to make these things in quantity. I really wanted to laser cut them, but it looks like that's not really going to work out. If you know of a really great material that comes in 10 thou thickness, is rigid and strong enough to be used as a front lens over these displays, and has the red filter that's actually transparent and not just translucent, go ahead and put that down in the comments. I'd love to hear about it, but at this point, I think this is really my best option. Plus, because it has the protective film on both sides, I can cut it, leave the film on, and then when you get your kit, you can peel the film off and have a pristine, clear plastic surface to work with. So let's go over to the mill and put together a fixture to machine this stuff. False alarm, there's one more step here at the bench. Before we can mill out the blanks, we have to cut the blanks out of this material. And what I have here is a guillotine style paper cutter. So this has got a clamp to hold down a large stack of material underneath the blade, and then it has a large guillotine style blade that comes down and slices through. This thing will cut a phone book in half. This is the kind of paper cutter that you would use to cut through 200 sheets of paper or to trim the edges of a book after binding. Now, this kind of a machine, while very cool, is also quite dangerous. You definitely want to keep your hands away from this part of the tool because there's grease on the back of the casting here, and if you get your hands in there, you'll get grease all over your fingers. So let me set the fence here, and let's make some cuts. The part is 80 millimeters long. So let me set the fence to 80 millimeters. Okay, that looks about right to me. Now I'm just going to slide the entire stack of 9 sheets of material in here with the protective plastic still on it, and I'm going to slide in a sheet of cardboard over the top just to make sure the clamp doesn't mess up the plastic. Bring the clamp down, that nice and tight, and make the cut. And that's it. Nice and clean. 80.06. 80.2. I will take that. And of course, that's just totally just luck that I got that close. Let me go ahead and slice the rest of these off. And there's our stack of blanks, all beautifully cut to size. Now let's go over to the mill and make a fixture to put the holes in these and cut out the pocket for the buttons. Okay, the first part I want to make here is the clamp that holds down the pieces of plastic while they're being milled. And that's just going to come out of a 3/8 inch thick piece of aluminum. And I'm going to put that in my shop-made Talon jaws here. Clamp those down, get a good bite into the part, then back off and just snug it so that it's got a good purchase because I got an indentation, but it's not pushing so hard on the part that it's going to flex. So that's set up, and then according to my setup sheet, my 0 is on the top center. Use the Heimer here and find the 0. And because I'm totally chicken, let's just check G0, X0, Y0. So we'll go to X0, Y0. That looks like the center of the part. Let's see if I can take the Heimer out without dropping it again. And the first tool is going to be the Superfly to face off the top. Now, if you hadn't noticed, I did not use the air wrench on the Heimer because it turns out if you're holding onto the body of the Heimer and you hit it with the impact wrench, you can actually knock the concentricity adjustment out. And you have to re-zero it. And I don't want to do that every time I use it. When we get the new spindle on here with the taper automatic tool changer, that won't be an issue. That surface is just so pretty. I love the surface finish that this tool creates. Next up is the spot drill. Next tool is a number 7 drill to drill out some through holes for clamping screws. Then number 29 drill for the actual holes that are going to end up being the drill guides. And then a 3-flute carbide end mill for milling out the shape of the part and contouring it. If it's going to crash, this is where it's going to do it. And there we go. So the clamp is all contoured out now, and all we have to do is remove this top hat. Now when I flip it over, the setup sheet for the CNC program calls for locating on this corner as 0, 0, 0 with it upside down. But of course, I have no way to get my measurement into 0, 0, 0 because I can't get the Heimer in and touch this surface. So what I'm going to do is I'm going to put some parallels in here, and I'm going to clamp up a 1, 2, 3 block and a stop. And for the offsets, I'm going to set my Z offset to 1 inch because I'm actually going to be finding on the top of this, but what I really want as my 0 is the bottom. So let's get this corner. And I'm moving real slow here because I do not want to crash the Heimer and break another tip today. And we'll get the Z0, or more precisely the Z1. Now, to take off this top hat, there's no way I'm coming in here with a face mill and just plowing through this thing because it'll catch on this lip and it'll rip this part right out of the vise. What I am going to do is I'm going to come down with this end mill and I'm going to contour around the part to take the top hat off, and then I'm going to come back and face it off. And just because I'm totally chicken, I do not need this end stop, so I'm just going to take it out of the equation. That appears to have worked really well. I stayed 10 thou off of the side of the part, and I can feel about a 10 thou overhang all the way around the part, and it feels nice and consistent. So it looks like we got a good registration. Now we'll come back with the Superfly and just deck this thing off and bring it down to final dimension. Oh, once again, finish on that is just beautiful. Wow, what is not to love about that? Okay, I've got some burrs I'm going to take off of this, and then we can get set up and use as a template and see if we can mill some parts. Okay, I have the mini pallet here back in the vise in the mill, and I've taken a cut with the Superfly and just dusted it off so I know it's absolutely flat and level, and I've taken out most of the marks from previous operations. And the goal is going to be to lay down these lenses on here and clamp them with this clamp. But in order to do that, we need something to line it up against. So I turned these pins on the lathe, and these are 3/8 inch diameter steel pins with a 1032 thread on them. And these are highly concentric. They are all within a 10,000th of an inch of 3/8. And since I did a single point thread cutting operation on these, use the electronic lead screw to cut these 1032 threads, I know that they're absolutely concentric with the body of the pin. So when I put these in here, I've done some measurement and I get within about 1/2 thou. And that parallelism issue with it being out by maybe 1/2 thou is because of these holes. These holes were spotted and CNC drilled, but because they're drilled, they're off slightly. But 1/2 thou over 2 inches is not enough parallelism concern for this operation. We're just putting some holes in plastic lens. So I will drop these in here to use as a fence. And then I didn't bother putting any kind of features in those for tightening them. And I'll just use a little strip of copper and some parallel jaw pliers and just snug those down. And those will not go anywhere. Now that then gives us 3 locating points so that we can get this squared up. And lo and behold, the holes actually do line up with 2 of the holes here in the base. So let me grab some lenses. And honestly, I don't really know how this stuff is going to behave. So I've just grabbed 10 of these. Got them in a nice neat stack. Going to line them up against the pins. Then I'm going to bring this in, line it up against the pins, and drop it straight down on top. Let me grab some 1032 screws. Okay, so those are clamped down securely. They're not going anywhere. Now we can do some milling. Now the idea is going to be to come in and put the 4 holes. That part I'm not expecting any problems with. And then what I'm going to try to do is come back in here with a 1/4 inch end mill and just plow this out and see if I can cut this material out, and we will see if that works. But first, let's get some zeros on this, and this will give us one more chance to break the Heimer. And then we should have Z0 set down here on the bed, because I had that set when I came in with the Superfly, and so this should be 0. Let's check it. Let's start with the small drill. Now, it wouldn't surprise me if this drill kind of hits the edges, again, because the setup is different. You know, if we scrape a thou off the inside of the drill guide, it's not a big deal. And I want air for this, but no coolant. Well, it looks pretty good. I didn't see any melting or anything. Now we're going to come back with a 1/4 inch tool and see what happens when we go through here. Of course, since this is the last cut of the day, if there's a problem, this is where it will be. I can't really tell. This is puffed up a little bit, but I think it's held pretty securely under the ends there, so we'll try it. If I have to put gauge pins or something in these holes to hold it in place, or put another clamp out here or something, I can, but let's see what happens. Well, I didn't expect it to rise up like that. Probably would have been better to conventional mill that instead of climb milling it. But all in all, I'm pretty happy with that. Let's see what the parts look like. Well, those look great. I got no complaints about that at all. Let's go over to the bench and see how they fit. I went ahead and off camera ran the rest of the blanks through, and so now I've got, I don't know, 100, 150 lenses. I didn't really count. A lot of lenses. Let's go ahead and take one of these and assemble it into the PC board. See what it looks like. I've got a printed bridge that'll go on there. Then the lens will sit on top. Let me peel the plastic off. I already took it off of one side. Peel it off of the other. So that fits on like that. And then the PC board goes on top. Oh, I need some buttons though. Some buttons here, snap those in. Yeah, it sounds like my neighbor just decided to mow his lawn. That's fine. And there we have it. See how the buttons feel. Buttons feel just a touch tight, honestly. At least this one down at this end. Ultimately, the fit of this has to do with the precision of the 3D printer, and so you get the precision of the 3D printer printing the button, you have the precision of the 3D printer printing the bridge piece, and then you have the thickness of the lens in there, and so it's a stack up that's got to fit properly. So I'm going to go back and I'll do some tuning on the buttons to get the fit right, but we're very, very close here. Well, that's interesting. The thickness of the back on these buttons is 120 thou. And the thickness of the back on these buttons is 140 thou. So clearly I've got some kind of problem here with the 3D print that I will have to get sorted out. Okay, and that is that assembled, and it should drop right into this bud box, and that actually fits very nice. Let's take this over and put it on the lathe so we can power it up and see how the display looks. Well, here it is on the lathe, and I have to say, looks pretty sharp. Let's power it up. I'm pretty happy with that. The lens, it's not quite as dark as the stick-on film, but it's dark enough. I'm very happy with that. It's very easy to read. The buttons, this is a little bit different kind of flexible material that I used for these, and I'm very happy with how they feel. Obviously, I've got an issue with the thickness of the up and down toggle buttons. I'll have to go back and get that sorted out and get my processes worked out there. I made some changes to the CNC program for milling out the lenses. Got that sped up a little bit. We've got the PC board worked out. That fits pretty well. I got to sort out the buttons, and then the other thing that I want to do before I start making these available for sale is I want to pick up some more of these the PC boards with the buttons and the display on them. I have been hearing rumors that some people have been buying these and the layout of the board is a little bit different and it doesn't fit my face plates. So I just ordered 100 of those. I'll get those in, make sure that everything fits, and then that will allow me to put some kits together that would have this entire, the faceplate, the PC board, the lens, and all of the 3D printed parts, and maybe the screws to put it together. I'm probably not going to buy and resell the bud boxes just because those are readily available everywhere. And you can also use this same panel and put it in whatever kind of enclosure you want. So you can have that to look forward to. I'll get that wrapped up, and as soon as I have something available, I will make an announcement. In the meantime, if you are enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.